Now, if there's one thing that computers are famously good at, it is doing math. But what does addition look like in binary? If we have 0 and we add 1 to it, we get a 1. If we have a 1 and we add 1 to it, we get 2. However, you may have noticed that in order to go from 1 to 2, we had to actually set the first bit to 0 and the second bit to 2. And then if we want to go to 3, we need both of those first two bits to light up. Now that we have 3, if we add 1 more to it, we get 4. And what we're going to notice is there's a cascading effect that happens. Because if the 1's bit is already set and we add 1 to it, then it's actually going to clear, and we're going to carry that 1 over to the next place and do the same process. If that's already set, we're going to clear it and carry it over to the next place. So how do we do that using our good old logic gates? Well, we're going to start with the simplest possible addition. We're going to just take one bit. We're going to take the 1's bit from two different numbers. So we're going to add 0 to 1. We have our 1's bit, we have our 0's bit, and we have a 1 as the result. Now, if we wanted to add, say, 1 to 1, we don't have any logic gates here, so it kind of breaks down. The logic gate that we want to use in order to compare those two bits and tell us whether or not that bit should be set, the exclusive OR gives us that logic. It'll say, if one or the other, but not both, and not neither, light up as a 1. How do we now inform the next place that it's going to be incrementing by 1? How do we fill this 2's bit? Like, when we add 1 and 1, we should get 2, right? The trick is we're going to want to take those two inputs and we're going to want to AND them together, because we want to say if one and the other, then we should have a true value. When we compare these two bits together, we have 3 possible outcomes. The first possible result, if they're both 0, then we put 0 in this place and we don't pass anything along to the next place. If one of them is 1 and the other one is 0, then we want to put a 1 in this place, and we don't need to carry anything over. And in the event that they are both 1s, then we want to leave a 0 in this place, and we want to inform the next bit that we're going to be adding 1 more to it. So we want to carry that bit over. Here we can see 1 plus 1 equals 2. A 1 in the 2's place and a 0 in the 1's place. Or this combination of an XOR gate and an AND gate to determine the result of the current place and whether or not we should carry 1 over to the next place is called a half adder. And that's because it only does half the job. But we'll get to that in the next video.